At just over 300 acres in size, the San Diego State campus is just large enough to entice students to use bicycles and skateboards as a primary mode of transportation. San Diego State has a trolley station and bus stop on campus that allows students living off campus to bring their bicycle or skateboard with them to campus. As the number of students bringing bicycles and skateboards to campus increases, the potential for conflict with pedestrians is inevitable. The design staff of AZTEC Engineering will propose and design a campus bikeway that is the most cost-effective while taking into consideration sustainability, cost, and above all, safety.
After evaluating the existing traffic conditions of the campus in regards to pedestrians, bicyclists, skateboarders, and vehicles, AZTEC Engineering came up with the following proposed route. The Highway Design Manual Class 2 bikeway is represented by the red route, where bicyclists and motorists will share the roadway, which goes through AZTEC Circle Drive, Avenue of Arts, and Scripps Terrace. The blue route represents the Highway Design Manual Class 1 bikeway, which will be exclusive to bicyclists and skateboarders only. This route is adjacent to the dorms and travels through AZTEC Walkway and Campanile Way. Alternatives considered by the design team included a bicycle bridge, a masonry barrier, concrete staining, and additional bicycle parking.
Presently, there is no safe and efficient manner for bicyclists living at the college dormitories to traverse College Avenue in order to get to campus. Therefore, a bridge designated for bicyclists was considered as a possible solution. Currently, the total population residing at the dormitories is approximately 2,163. A field count of the number of bicycles at the dorm determined the number of potential bicyclists to be approximately 159. That only accounts for approximately 7% of the total population at the dormitories.
Based upon soil data analysis provided to AZTEC Engineering by the school architect, which included the results of a CPT test, we were able to classify soil type for each layer. The following profile determined 9 different soil layers and the water table that is located at 3 meters below the surface.
2 design ideas considered by the design team included a cantilever extension off of the existing suspension bridge over College Avenue adjacent to the dormitories, and a second idea was to construct a separate but similar bridge exclusively for bicyclists adjacent to the existing suspension bridge. Potential problems existed with both design ideas. There are 3 large electrical cabinets present that could make the construction of formwork quite difficult, and due to its proximity to Quequecala Dormitory and the alley behind KB Books, there is inadequate space for a parallel bridge. An additional issue were existing stairs that service the bridge. Both designs would have required the demolition of these stairs. The cantilever idea would have resulted in upsetting the current design and loads for the existing bridge. Most of all, cost of a bridge for exclusive use by bicyclists. Due to the high cost of construction, low bicycle demand use, and problems with existing features, AZTEC Engineering made the decision to abandon the design.
The most important aspect of our design was to ensure the safety of all students, including pedestrians, bicyclists, and skateboarders. To achieve our goal of safety, AZTEC Engineering decided on a 4-foot-high masonry wall to separate pedestrians from bicyclists and skateboarders along Campanile Way. The initial task completed by the design team was to determine the amount and makeup of the traffic flowing into the campus via Campanile Way. The purpose of the study was to determine the peak hour volumes and percentage of pedestrians, bicyclists, skateboarders, and vehicles entering Campanile Way. In order to complete this task, members of the team conducted surveys at various locations providing access to Campanile Way, which included AZTEC Walk, Open Air Theater, the Music Building, Hilltop Way, and the Love Library. The surveys were conducted between the hours of 0845 to 1500 hours. The results of the survey indicate that the majority of the traffic entering Campanile Way were pedestrians. On all days, pedestrians accounted for over 91% of all traffic, while bicyclists and skateboarders each accounted for over 3% of all traffic. Vehicles, which included carts, automobiles, and trucks, accounted for the remaining traffic. Nearly all the bicyclists and skateboarders and about 5% of the pedestrians were utilizing the existing bicycle lane.
According to code requirements, all footings must extend at least 12 inches into undisturbed natural soil or compacted soil which has been compacted to 90% density. Masonry units should be medium weight units with maximum shrinkage of 0.06%, F'(m) of 1500 psi. All head and bed joints should be 3/8 of an inch thick. Bed joints of the starting course over the concrete foundation may be between 1/4 to 3/4 of an inch. Mortar mix must have a compressive strength equal to 1800 psi minimum. Mortar for use in masonry construction should conform to ASTM C270. Grout must have a compressive strength equal to 2000 psi minimum. Reinforcing steel must be deformed and comply with ASTM 615, grade 40 or 60. When one continuous bar cannot be used, a lap or splice of 40 bar diameters is required. The following detail was generated based upon the San Diego City Code, ASTM criteria and design calculations. Utilizing 8 inches fully grouted medium weight masonry block, the required horizontal reinforcement was number 3 bars at 16 inches of center. The vertical reinforcement required was number 4 bars at 24 inches of center.
The masonry wall designed to enclose the bicycle path will consist of a 4-foot-high wall on each side of the path along the Campanile Way route. The 625-foot wall is broken into 6 sections to allow for the pedestrian traffic to cross the path. The 2 walls are 5,000 square foot total, with a materials cost of approximately $6 per square foot. This includes $8,100 for masonry blocks, $18,000 for concrete and mortar mix, and $3,900 for the number 3 and number 4 steel reinforcing bars. With a labor cost of approximately $20,000, the total cost of the entire 2 walls is $54,000.
To establish Class 1 bikeways, the design team determined the most economical and safe design would be to stain existing concrete, supplemented with striping and signs. The concrete staining design will be based off the criteria in the Highway Design Manual for Class 1 bikeways. The stain will be a water-based polymer stain in Baja Red. There will be a minimum width for a 2-lane bikeway of 8 feet. However, 12 feet is recommended in the manual. A 6-inch wide by 4-foot long broken white stripe will separate the opposing lanes of bicycle traffic. Application and placement of signs were based upon the MUTCD Section 9B.01. For example, the Share the Road sign will be mounted at various locations along the shared bicycle vehicle routes on AZTEC Circle Drive, Avenue of the Arts, and Scripps Terrace.
The total area of the path to be stained is approximately 18,600 square feet. The white paint, Baja Red stain, and stain sealer accounts for a $2,200 material cost. The labor for applying the stains will require a 4-man crew and 9 full working days to allow for the pressure washing of the path, the application of the stain and sealer, and appropriate drying times. The cost for the 9 days of labor is $11,900 for a total concrete staining cost of $14,100.
One issue observed during observations made on campus was the lack of parking for bicyclists. The blue stars represent the locations of existing bicycle parking, which include inverted U's, waves, racks, and a bicycle barn. The red stars represent areas around the dormitories in which additional bicycle parking is needed. The red rectangle represents the location of a proposed 160 capacity bicycle barn that will be free of charge to residents of the dormitories. The red rectangle depicted on the west side of AZTEC Center is the location of a proposed 12 bicycle lockers. Each locker is capable of holding 1 bicycle, and there will be a fee associated with the rental of the locker. Depicted here are locations of the existing and proposed bicycle parking for the North Main campus.
One proposed type of bicycle parking is the inverted U. The criteria used in determining that the inverted U rack was most adequate is as follows. It supports the frame of the bicycle and not just one wheel. It allows the frame and one wheel to be locked to the rack when both wheels are left on the bike. It allows the frame and both wheels to be locked to the rack if the front wheel is removed. It will allow the use of either a cable or U-shaped lock. It will be securely anchored to the ground. It will be usable by bikes with no kickstand. It will be usable by bikes with water bottle cages. And finally, it will be usable by a wide variety of sizes and types of bicycles.
The proposed 5-inch slab on-grade bicycle barn will be 28 feet by 50 feet and located adjacent to Queequeg Dormitory. The wood-framed roof truss will be supported by 6 8-foot-high masonry columns. To minimize cost and bearing load, chain-link fence was used as walls. The following codes were adhered to when designing the bicycle barn. A minimum footing depth below natural and finished grade shall be 24 inches. Slab on grade and footings must be a monolithic pour. Footings reinforced with 4 number 4 continuous steel bars. 2 bars shall be placed within 4 inches of the top of the footing. Slab shall have a minimum thickness of 4 inches reinforced with number 4 bars at intervals not exceeding 18 inches in each way. Slab shall have minimum underlayment of 4 inches of coarse aggregate or 2 inches of clean sand. A 6 millimeter minimum moisture barrier is required beneath the slab underlayment and properly lapped at joints. Soil shall be pre-saturated to a depth of 18 inches prior to pouring foundations. Drainage shall be directed away from footings by sloping finished grade a minimum of 2% for a distance of 5 feet.
The following detail depicts the design of the slab on grade for the bicycle barn. There will be 2 footings running longitudinally along the 50-foot length of the slab. The footings will be 1 foot by 1 foot and 2 feet deep to support the load from the columns and roof.
To account for the excess of bicycles to parking storage spaces, an additional 36 bicycle racks must be included across the campus. The cost of these additional racks is $2,630. The 28-foot by 50-foot bicycle storage barn, built with 6 masonry block column supports, a brick facade, a wooden and galvanized steel panel roof, and chain link fencing and door, will have a materials cost of $15,750. Including labor for the construction of the storage barn and necessary bicycle racks, the total cost comes to approximately $40,000.
In conclusion, the final design proposed by AZTEC Engineering includes the following: a Class 1 bikeway, a Class 2 bikeway, a masonry barrier, a bicycle barn, and additional bicycle racks.
You're on.
The total cost for the aforementioned designs has been calculated to be $115,000.
One of the major components of our design was sustainability. All proposed designs are confined to the SDSU campus, and therefore objections from residents surrounding the campus should be non-existent. In fact, the implementation of campus bikeways could potentially decrease the amount of vehicular traffic in and around the campus. New bikeways will result in a profit to both the campus as well as the student population. Students will save money if they were to bike to campus, and campus facilities will not be required to construct expensive parking structures for the increasing demand. A healthy lifestyle is also being encouraged by this form of transportation. Environmentally friendly materials used during the construction of the proposed designs, as well as the transition from a vehicular form of transportation to one that utilizes bicycles, will result in a smaller carbon footprint.